I'm Nigel Umbayak, and welcome to Autodesk Virtual Academy, brought to you all by KETIV Technologies. Today, I'm joined by Matt Bussey, one of our senior solution architects on the team, and Matt's actually a person who usually works remotely, not from the office. Good morning, Matt.
Good morning, everyone. Thank you for being here.
Absolutely, and thanks again, Matt, for getting this together for us. So Matt, like I said, he's one of our senior solution architects, works primarily on our development team, and helps get automation projects out to our customers. He builds plans for those customers and helps implement those projects for them. So definitely one of the best people that I could have on here with us this week. And today, Matt's going to be going over some stuff in the Inventor API, some drawing automation techniques, and that's something that gets brought up a lot by a lot of our customers. I see some of you in the chat now that I have talked to in the past about automation, whether it be iLogic or the API, or using things through the job processor and Vault even for some sorts of automation. And hopefully we answer some of your questions today. Like I said, if you do have any questions, go ahead and type those in and we'll go ahead and take care of those. Matt, do you have anything else to add before we get started here this morning?
Just a couple things so you all know. For those of you who attended my ABA back in November, this is actually going to build on that a little bit. So I'm also making an assumption that you know at least a little bit about the Inventor API, so I will not be going in depth into things like object models and things like that. This is going to focus on things in terms of drawing automation that we typically see our customers struggle with that are relatively new to drawing automation, especially when they're having to understand, well, how do I create from scratch out of thin air? So this is going to focus on some of those types of issues that our customers most often struggle with in getting started.
Absolutely. And if you haven't seen any of those past webinars that Matt is referencing, those are all recorded, all on YouTube. Go ahead and take a look at them after the webinar today, and maybe catch up if you need to. With that, go ahead and take it away, Matt.
So let's do a little bit of an overview of what we'll talk about today. So there are three basic things that we see those who are trying to use the API for drawing automation struggle with as they're starting out or as they're trying to understand how to get the most out of drawing automation. The first is that how do they find the curves that they actually want to annotate, most typically dimension. So we'll talk about using something called attributes, how you define the attributes, a little bit of an idea of how to structure using them. And then I will show you in some sample code how we use those to actually find what we want to grab in a drawing in order to actually create our dimensions or other annotations. Then we'll talk about a little bit of common stubborn situations that comes about with dimensioning. We'll focus on linear dimensions primarily, but the things that we'll talk about can apply to other types of annotations as well. The last thing that we'll talk about is just a brief of how to deal with the scale of a view. This is something that, especially when you're trying to create a generic drawing layout logic, where what could be in that on that particular sheet could vary from something very small to something very large. How do you deal with the view scale as you're generating the views? So we'll talk a little bit about that as well. Feel free to, in the chat, ask questions as we go along. I'll try to remember to ask Nigel to stop me every once in a while to answer questions, but please feel free to ask. Also, I'm going to apologize. It is the middle of allergy season here in Arizona. So if you hear me, if I go mute for just a moment, it's because I'm just trying to clear my throat or cough a little bit. So, all right, so first let's talk about finding curves using attributes. And really it's more than just finding curves. It's finding objects in your part or assembly model to get the drawing curves from, okay? So what are attributes? Let's talk about that first. They're a developer's way of tagging basically anything in an Inventor document. It's typically attributes consist of three pieces: a set name. And for those of you who understand development speak, think of this as your namespace. Usually you want to have an attribute set name to get your attributes separate from anyone else's attributes. And I'll show you an example of that when we get to some of the demo, okay? Then there's a name, and that's, you can think of that as the variable name, and then there's the attribute value, which is the current content of the variable, okay? Makes sense? So in this example over here on the right, and I'll show you some more of that, if I wanted to basically attribute this face, I would give it, in this case, my set name is KETIV. For everything that KETIV does, we usually use our own name to set apart our attributes from everyone else's. This one has a variable name of angle linear dim, and I'll talk about that more in a minute, or in a few minutes when we get to our example, and its value is top, okay? You'll see another one down here. This happens to be on the bottom face that you can't see in this particular picture. Again, the set name is KETIV. It's for the angle linear dim, and it's the bottom. So you can probably see that the way that I have structured this, and again, we'll see it more in an example, is we are going to probably create something that I'm calling an angle linear dimension. And I need to know where the top of the part is and the bottom of the part is in order to create that dimension, okay? So why use attributes? And I'll show you how to create attributes in a minute. Attributes are not something you will see in the user interface at all, typically, in Inventor. This really is meant for API development work. So why use them? Well, you typically use them to tag something so you can go back and find it later on. That's the reason to use it. There are other ways you could do that though. Like you could name a feature something specific. You could apply a specific color and search for that, et cetera, et cetera. Most often the reason you use it is that it is hidden from your user. This is really important because for your automations, you want to make sure that your user can't mess with the stuff that you created so you can make sure you can find it again. And mostly that's true. The one case that's not true is that if they do something to, like, say, your part file where like this top face got completely deleted, well, then the attribute's gone, you're not going to find it. There's not really anything you can do about that. But you tend to use attributes because they're hidden. The API provides an engine so you can find it on the object it's on pretty easily. And it makes for a consistent way of keeping track of, quote unquote, your stuff. So this is the stuff either you created programmatically or that you're interested in, again, for creating dimensions, when you're drawing automations, things like that. So attributes tend to be a very handy way of doing all this, okay? Tagging for annotation creation. You want to create tags for specific types of annotations. This is kind of the strategy. Now that you know about annotations, how would you actually use it? The way that we use it typically at KETIV is we create annotations for specific types of dimensions we know we need to create, okay? So, and again, you'll see examples of this in a minute. So if there's a specific type of feature on a part that we know that we want to dimension in a specific way, we'll create annotation tags to make sure that we can find those things so we can dimension it consistently. We will also usually create an annotation, I'm sorry, this is attribute. I'm sorry, I'm saying this. We will create an attribute for specific types of dimensions. We'll create an attribute for overall dimensions, et cetera, et cetera. So one of the things that you will find sometimes is that you may be creating a lot of different attributes for different specific situations that you want to dimension. But a lot of this is, you can think of it as you're creating your design intent, okay? And those tags are helping you with the design intents to help you with your automation later on. So it works best if you have a strategy for that dimensioning. So typically you're going to lay out a sheet or a view. Usually we do that by actually creating it manually up front. We figure out our views, then each view we figure out which kind of dimensions we want and where, and then we figure out what the purpose of the dimension is. And we use that to figure out our structure. And again, I'll show you a little bit of that idea when we get to our examples. Now, what should you tag and why? Or what should you attribute and why is probably a better way of saying it, okay? So we typically, for most of the dimensioning that we do, most of the dimension automation we do, we're looking at two different levels of where we typically put attributes. The first is at a component definition. The component definition is what's in a part file or an assembly file that basically holds the recipe for creating the part or creating the assembly. And we will typically tag the component definition when we are creating drawings for large assemblies that have lots of parts in them, but we only care about specific parts. And we use that so that we find, hey, we only want to care about doors, let's say. Okay, if I've got like a clean room design, or I've got an air handling unit, or say I've got like a mixing tank with a manway in it, we'll tag those things as you are this type, so that when we get to the point where we're, say, putting a balloon on that for bill of materials purposes, or creating a specific type of dimension for that specific type of object, we're not sorting through all the other objects, having to say, what are you? What are you? Or relying on things that are very unreliable, like file names, which users can change, or even iProperties or parameters, which again, users can change. So by putting an attribute in the component definition, we know what it is. Typically, we'll do something like, we'll name it a component type, then we'll have values like doors, windows, nozzles, fans, cylinders, things like that. So that it narrows down what we're looking at, okay? Once we narrow down all the stuff in an assembly, then we can start looking for specific pieces of geometry within those target components, okay? And again, it's better than trying to use a property or a file name, because users can change those, and if they change those, they can break your automation, okay? Now, one of the other things that's pretty common when we see folks starting off with using attributes and trying to do it for dimensioning, they tend to put them on edges because that's what they think about when you're dimensioning. But the truth is that edges are probably the worst thing to put them on. One is that and faces tend to be better. So why? Faces are more stable than edges. If geometry changes, edges get deleted and recreated all the time. Think about when you're doing projected sketch geometry. Projecting a face is usually more stable than projecting an edge. Not always, but usually, okay? One of the other things that if you're looking for a face rather than a hard edge in a model, is it gets around the silhouette edge problem. What is a silhouette edge? Well, if I have a cylinder, okay, the truth is that edge and that edge aren't really edges in the model, okay? They're what we call a silhouette edge. So you can't actually tag those. They don't physically exist in the part model, but you can tag the face, and then the drawing environment, you can give it the face when you're looking for drawing curves that are created from this, and they will understand to hand you back these two edges that are the silhouette curves, okay? Again, we'll see this in an example. Also, by tagging faces, that means there's fewer things you have to attribute, so less work for you. Also, just one thing to remember, and we'll talk about this a little bit in the examples, when you're searching for things, you got to remember to change your faces into face proxies if you're grabbing geometry from an assembly. We won't go into great detail about that. If you have questions about what a face proxy is, go back and look at my, I believe my earlier ABA goes into that a little bit, but also if you got questions about that, just ping us and let us know, and we can help you walk through that, okay? So that's the basics on attributes, okay? And I'll show you examples of these once we go through kind of the overviews, okay? Now, dimensioning stubborn situations. There really are kind of 3-ish, 4-ish situations that we see come up a lot where folks struggle to get the dimensioning right using the Inventor API. So the first I would say is trying to create a linear dimension to a nonlinear curve. So this example right here is a perfect example. That's a circular curve, and trying to get that point can be difficult sometimes. Although the Inventor API has ways of making it easy, especially if it's like in a quadrant type of situation, okay? That's one of them. And this will talk about the point intent enumeration, or the point intent enum. Lines at an angle. So if you need to get an overall dimension of something like this with this funny shaped wedge, one of the frustrating things for especially a lot of newcomers to the Inventor API is that you cannot give anything a point. None of the Inventor dimension commands accept points. They accept what's called a geometry intent, and geometry intent have to be based off of curves. which is like this curve right here and this curve right here. So understanding how to create like this vertical dimension off of those two angled curves can be frustrating. So we'll talk about that. This is where we start getting into creating an intent, what's called a drawing intent off of a 2D point, okay? But you have to also have the curve as part of it. Another situation that has to do with angled curves and something that is not obvious to most people, it's documented, but it's not obvious, is that when you're creating a linear dimension, you're almost always creating an aligned dimension, okay? And most of the time that's fine. But in a situation like this where I say I need this overall dimension right here, you have to know to tell it that, hey, you gotta force it to be a horizontal or force it to be a vertical. You'll see this in the Inventor UI if you're creating these dimensions manually as well. You'll see this where you have to click in a certain spot to say, no, I don't want it aligned, I want it vertical, or I want it horizontal. We'll show you the API equivalent of that. There's also other situations where you need to create dimensions something like this, but for various reasons, like this curve is not the right curve to use to try to get that point. Really what you need to use is this curve, and they're basically parallel to the actual dimension itself. So how do you create that? And this is a combination of things, a 2D point intent and forcing the horizontal vertical at the same time. And again, I'll show you more of an example of this, of why you would need to do this in this situation, okay? All right, so those are the stubborn situations that we're gonna go through, and I'll explain how to deal with them when we get into the example code. Last thing that we'll be talking about is dealing with the view scale. So think of it this way. I am tasked with creating some generic drawing automation routines. These routines are going to create a sheet with 4 views on it, front, 2 sides, and a top view. And I have to use this for a lot of stuff that could be created of various sizes. This cheese wedge part could be using the same layout logic as this very complicated test station assembly. And they're radically different sizes. This is probably only like 2 or 3 inches in diameter across, whereas this is several feet in size, okay? One of the things that a lot of folks struggle with is how do you get the view scale right? Now, part of the reason that they struggle with this is that you would think you could go to the Inventor assembly and say, give me a bounding box of this, and then calculate an accurate view scale from that. The reality is that it's really not that simple. That bounding box is sometimes approximate, and calculating the view scale to create the view up front can be difficult. So we've got around this, and the other thing is that you usually want to fit each of these within a specific size of space on the sheet. You don't want it to go any bigger than that size. You want to make sure that it doesn't go any smaller than that size, because then you've got a lot of white space. So we've given up here at KETIV, we've given up guessing up front what the view is. We create the view and then we calculate it. You may be saying, what? Yeah, we've actually found this to be a lot more stable and give us a lot fewer gray hairs trying to do it. Basically, the way that we do it is we try to figure out the maximum extent the view can take up on the sheet. So we basically figure out what the bounding box is on the sheet. This is the biggest that we want each view to be, okay? And really the way we calculate that is usually we create like a sheet sketch on the drawing sheet. We create an example drawing for us to use as a guide. We create a sheet sketch and we draw a rectangle around each view, and we basically dimension that rectangle. We have to make sure that we're using centimeters, because the units, Inventor's internal units are all centimeters. So you got to remember that what you want is the centimeter size of that rectangle. So in our automation, usually we just create the view with just a 1-to-1 scale, or we might make a guess, but we know the guess is usually going to be wrong. After that, we then ask the view, what's your current width and height? And then we use that initial size and the target size that we actually want it to be, and we just calculate a new scale and we apply it to the view. You know, when you're doing that visibly, yeah, you'll see the view flash big, then flash small. Quite often though, it'll be so fast the user won't even see it happening. And if they do, I mean, how many times have you manually started creating a view on a drawing only to place it and then change the scale anyways? Because Inventor guesses wrong too, quite often. So again, we'll see examples of that. So before we get into demos, are there any questions that we have at this point before I actually start demoing the actual code itself? Show you examples of this and how to take care of them?
Yeah, we'll give everyone another 10 seconds or so to ask anything that they do have. Look like there's any questions. There's just some comments that have come through. So let's keep rolling here, Matt.
All right. So first thing we'll look at is let's look at actually applying attributes. Now, you can write code to apply attributes to anything, but doing that to kind of set up attributes up front, say like on template parts or things like that, is actually very tedious. Fortunately, old colleague of mine, Brian Eakins, created something called Attribute Helper. We talked about this in my last AVA. So go back and look at that if you want to. There's also links there to where to get it off of Brian's website. Attribute Helper allows you to come in and basically select geometry or almost any other object and apply an attribute to it. So I'll do an example here of like this front face. So once Attribute Helper is running, I'll select that front face. I'll right click and I'll add an attribute set. In this case, like I said, it asks for a set name. So I'm going to give it KETIV, which is what I give all my attributes. So you can see here, if I expand this out, I've already got two faces attributed, and they have a set name of KETIV. I also have the part component definition. I'll show you how to do that in a minute. But once I have this here, I'll put it in. I right-click in the browser on the actual folder, which is the set name, and I'll add a new attribute. And let's say that this is for side dims, and this is the front. Okay. And then I can do the same thing here. So this is if I was going to do a dimensional side view. Okay. I add the attribute, KETIV, and then come in and I'll do add attribute side dims, and I'll put back. Okay. So here's part of what we're talking about in terms of, and I'm going to take a quick screenshot of this and kind of blow it up so it's a little easier to read as we're looking at it. Okay. There we go. So you can see kind of the structure that we've created for this particular automation for attribution. So everything's got a set name of KETIV. Okay. That's the attribute set name that we're using. So, and I've got basically a couple of different attribute names that we're using for specific dimensions I want to create, okay? So I have here something called a wedge dimension or wedge dim, okay? And there's the XZ flat, and then I have another wedge dim here that's a circular curve. So this is going back to this right here, where I want to create a dimension between this flat face, okay, and this circular curve. So I've attributed the faces that are going to generate those curves in the drawing, all right? The other thing I've done is that on the component definition, you notice when I select that, nothing in the window is actually selected, but the curve linear dim.ipt in my browser is selected. You basically can right click on that to actually create, here, let me try this for a second. Start this being a little persnickety. You can right click on that to add an attribute set to the actual component definition, okay? And that's what ends up creating this in the attribute helper. And here I've got a component type, and this is a cheese wedge component, okay? All right, so this is how we typically create attributes up front. Rather than writing code to actually programmatically add the attributes in, we do that sometimes, but more often than not, we're using Attribute Helper to go in and define all of our attributes up front in our template parts, so that when we copy these and use them in our automation, we're getting that at the end. Okay, I'll show you another one. This is a linear widget that we have some attributes already set up in. This one, again, the component type, this is a wedge widget. It has different faces already. So we have a cut dimension face there. That's the inside face for the cut dimension. There's the outside face for the cut dimension. Those are the dimension types I'm going to be creating in my drawings. And then I also have for my linear dimension across angled stuff, I've got my bottom face there and I've got my top face here, okay? Now, one of the things I want to show you before we get started, there's a reason I did this and it'll become more clear as we actually get into the automation, but this wedge has the ability, let me go to the front face here, where this bottom face may be angled this way or it may be angled down. You'll see this as soon as I run it. I've got a little iLogic code in there. So part of the reason that I have to use this face right here to figure out my length of cut is that this bottom face will appear and disappear, and the actual cut that I want to dimension in terms of its height may or may not intersect with this bottom face. So I don't want to use this bottom face because it'll be in a different position and may not be part of the dimension I want to create. And I don't want to use this face down here because it may or may not exist depending on which version of this widget I'm using. And hopefully that makes sense to everyone. It'll probably make more sense as I actually go through the example, okay? So this is why I've attributed what I've attributed and why it ends up becoming the problem that I need to solve in terms of creating the dimension the way I need to create it. Any questions on setting up attributes, kind of defining things? I know we have one question of, would you ever use multiple set names on a given part or assembly? Yes, you can. Actually, I meant to show that in here. Part of the reason that you want to make sure your set name is unique to you is that there can be other stuff in here that you didn't create that's created by other Inventor add-ins. So for example, I said there's a little bit of iLogic code in here. If I look on the document class, the iLogic creates its own attributes with its own set names for various reasons, okay? So in this case, it has a list of rules and it has a rule itself. So the rules that you have inside of part files for iLogic actually are stored as an attribute on the document itself, okay? And I don't want to run into any of these names on accident. We typically will, we will usually only have one set name that we use, but it depends. If we are writing code for ourselves to reuse in multiple projects, it'll usually have something like the attribute set name KETIV. If we are writing code that we are giving to a customer, we'll usually use an attribute set name that is specific to that customer. And sometimes we'll have a mix of both. So it really depends on what your needs are. You just gotta know that you always have to have a set name for an attribute. It always has to have an attribute name or a variable name, and it does not always have to have a value, although more often than not, you'll find you need a value to differentiate. Any other questions? Nope. All right, so let's take a look at some of the example code. So first things first, I want to create the dimension for this wedge. It's basically the dimension between this line and the bottom of this curve. Now I've set up some code. I'm not going to go through it in great detail, but I'll show you some of the things that are going on, and we'll step through it to see what's actually happening. So when I start this code up, I press the button to give me the wedge, give me the dimension for the wedge. It's going in and it's getting the active drawing, it's getting this view, it's getting its sheet, it's getting transient geometry because I may or may not need that. I can't remember in this one. I think I set this up and don't need it. But then it's got to find two curves. It's got to find this flat curve and it's got to find this circular curve. So here's where I go in and I have this find curves by attribute. This is from our last ABA that I did. So this code comes in and you hand it an attribute and it goes through the object and it says, okay, hand me back any of the drawing edges that this object in this file can create, okay? We're not gonna go into that depth, but it is there and you will have access to the sample code. But you notice again, my set name my variable name and my variable value. Okay, I want to find the circular curve specifically, so that's what I'm getting. Then I want to find that flat curve, which is this one right here. Okay, once I have that, I need to create geometry intent. That's what you actually give to the dimensions to actually create the dimension. I got to get a placement point for that dimension, and then I will actually create the linear dimension. So let's go ahead and run this code on this drawing and see what happens. Okay. And this will show us the first problem that most new users tend to get into. So I'm going to dimension the wedge. So I'm in debug mode. I'm going to step through it. Okay. The first thing it's going to do is it's going to find my circular curve, and I'm going to use my debug fake highlight command from my last ABA. Again, if you want to know more about that, go to the last ABA. It basically goes in and it changes the line color and line weight so that I can see what it is selecting. Make sure I'm selecting the right thing. Yep, it selected what I intent, so I create my intent. It selected the right curves, so I create the intent for the curves, my circular intent, my flat intent. Give it a placement point, and I create the dimension, and look what happened. Well, by default, Inventor, if you select a circular curve and an edge, it's going to always choose the center of the circle. But I really want it to get the bottom of this circle. This is where the point intent enumeration comes in. So when I'm creating my intent, I can pass it this enumeration, and this is in the Inventor help. You can go search for it in Inventor help. It's called point intent enum. There's a bunch of values that you can pass for the intent to tell it, no, I really want this. So the ones I'm most interested in are these right here. You notice the circular bottom point, circular left point, circular right point, circular top point. I want the circular bottom point, okay? So I'm gonna stop my code here for a moment. I'm going to undo these 3 steps. So I will come into my code and let's make sure I'm grabbing the right one here. I've actually already written this. So this has to do with the circle. This has to do with the intent you create, not the dimension command. Again, this is something that sometimes people get mixed up on. When I do my create geometry intent, I give it the curve, but then I can give it an optional value of this point intent enumeration, and I'm going to give it the circular bottom point intent. Okay? When I do that, instead of so this refines the intent. You can think of it that way. It's saying not just this curve, but this point on this curve is what I'm interested in. So when I'm doing that, again, I'll step through this so we can just see it. So there's my circular curve. There's my flat curve. I create the intents, my placement point, and then when I create the dimension, it's now understanding that my intent is not just this circular curve, but it's this specific point on the circular curve. Okay? All right. There was a quick question I just happened to glance at. No, extension methods do not work in iLogic. They are a compiler trick that the .NET framework uses in Visual Studio, and unfortunately, they do not work in iLogic. I'd love it if they did, but they unfortunately don't. Extension methods you can write as just standard methods. Again, check our last AVA, but on the last AVA I did on API stuff. But you can write them just as standard subroutines in iLogic instead. They're a little more awkward to use, but you can create the same code. Okay. All right. Any questions on that before I go on to the next intent problem?
You're good to go, Matt.
All right, so let's go on to the next one. And this one we'll be looking at this wedge shape. So the next problem that we want to do is we want to create an overall dimension from the top and the bottom. And this is tricky. Part of the reason it's tricky is that, again, let's go back and look at the intent. The point intent enumeration. The point intent enumeration does have some things that look attractive, like get the bottom right point intent, bottom middle point, bottom left point, the top left point, top middle point, top right point. So at first glance, you would be tempted to use the same thing that we did for the linear dimension, for the linear dimensions of the circle curve on here. But here's the problem. This bottom point down here is not always going to be on the left. Because if I use this wedge widget in a different form, like this, well, that point's on the right now. So unless I have other logic to figure out which intent to use, which of these intent enumeration values to use, this really doesn't work well for what I want to do. So another way that you can refine your intent is by giving it a specific 2D point to use as the intent. Okay? So here's what we're going to do. Again, one of the things that I've done is for drawing curves. Let me find it from here. There's also a second problem in this is that if I don't give it an intent, you can also get some funny results, okay? So let's see what happens if I don't give it, if I just give it a normal intent. Actually, let me stop that. Let me walk you through the code real quick. So this code is going to come in, it's going to do similar things. It's going to get the top curve based on my attributes. It's going to get the bottom curve based on my attributes. And then right now, it's just going to create just a basic intent off those curves and try to place the dimension, okay? So when I do that here, I'm going to dimension my linear angle. Again, I will step through this so we can see what happens. It's finding the right curves, okay, getting the intent, the placement point. Look what happened. I want an overall dimension. I don't want an aligned dimension, okay? If you only give it two curves that happen to be parallel to each other, then it's almost always going to give you an aligned like that, and that's not what we want. So this is what, and you'll also notice that it's probably, yeah, you can see it's not even figuring out what point on which side to use, okay? So let's undo this. And instead, let's go in and let's do something more specific. I'm going to comment those out. I'm going to bring these lines in. What I've done is I have written an extension method. Wait, this is the wrong, oh, sorry, this is the wrong one. Let me get the right one. Here we go. I was in the wrong command there. Let's get that. All right. I've written some extension methods here, and again, you could rewrite these as just standard functions, but give me the high point and a low point. Now, instead of an enumeration, you can also pass an actual point 2D object. So what I've done is I've written some things to look at the start point of the curve and the end point of the curve, and I look at its Y value. And I say, hey, if the start point is higher than the end point, then pass the start point. Otherwise, pass the end point, okay? Now, why do I do that? I don't actually know which of these points on the curve is the start and the end, okay? So I have to look at both of them. I also have, like I said, I have one for a high point. I have one for a low point. I could also create these for like leftmost and rightmost as well. I don't have those routines written for this particular demo, but I could. Okay, so when I come in and I give it more of an explanation of an intent, this will get closer to what I want it to be. So I want it to give me the high point and the low point. Okay. So again, we will walk through this. Now, it grabbed the points, but you'll also notice that this is an aligned dimension again. It's not a it's not an actual vertical or horizontal. So I've got to force it to be vertical or horizontal, okay? The default for linear dimension is always aligned. So I got to tell it, no, I really don't want it aligned. I want it to be horizontal or I want it to be vertical. So that's what I'm going to do next. If I come in here in my dimension, and again, this is something that most time new users don't realize, that they usually see, oh, I can do a place, and a lot of times it's because they're looking at examples, okay, and they're not, and the documentation isn't always clear, to be honest. They'll understand, hey, I got to get a placement point, I got to get a top, I got to get in two intents, two different curves. But then the next optional variable is you can come in and do a dimension type enumeration, and it can be vertical, horizontal, linear. There's also things like radial versus diameter, things like that. So I'm going to tell it specifically to do a vertical here, okay? So again, we'll walk through that real quick. This time it should give me the overall dimension that I want, okay? And again, by using it this way, if I have this situation, I don't have to worry about which of those points is really the one I actually want, okay? All right. Oops, no, that's not what I wanted to do. All right, let me come back here. Let me do this. Set up my drawing for one last one, for dimensioning. Now again, as I showed you before, because of things pop back and forth with this bottom cut right here, and if I want to create basically how big this cut is from this point to this point, okay, I'll be doing some of the same thing. Instead of showing you the before and after, because you've already seen it, let me come in and let me actually fix this. So you can use basically the same idea of using the points to define the intent and using the dimension type to force the dimension you actually want to create the cut dimension that you want to create here. Okay? So there you see it's selecting those two curves, and I want the bottom point of this curve and the bottom point of that curve. So again, I'm using these Y low points on both of them that I created. So I'm getting the lowest point on both of those curves because that's where I want the dimension to be across. And my placement point, and there we go. If I hadn't done that, I would get other weird results, okay? So let's look at two more things real quick because we're running out of time. And I'm trying to stay under my time because Nigel teases me when I don't, which I have a habit of not doing. Remember we talked about when you're creating views and you want to fit it within a certain box, but you got to guess at the scale. As I said, here at KETIV, we've actually just stopped guessing. We usually just create views like at 1-to-1 and then rescale it when it's done. So here I've gotten let's say I've gotten my automation to this point where I've placed this thing, but I want it to be within this red box. And this red box happens to be 28 centimeters by 28 centimeters. So this is a really simple thing to do. Basically, again, we have, this is an extension method, but you can write this in a different way. We take the view and we say we want it to fit within this box that's there's an X size and a Y size. And again, this is centimeters. So basically I calculate back out what the original scale was by taking the current width of the view and the current height of the view and dividing it by the current scale. This gives me the unscaled width and height. Then I calculate a new X scale based on what I want the box to really be, the new Y scale, and then I just take whichever the smallest of those two are, and then I apply it to the view scale, and that will rescale the view to fit within that box always. Okay? So you'll see it here when I press this button, I'll take the view and I rescale my view to fit within a 28 by 28 box. And this happens so fast, don't blink. Usually. Boom, there it is. The other views, since they're projected, are following its scale. Okay? And just to show you that there's nothing up my sleeve, let me undo this real quick. You know, like say if this was if I say I wanted it to be 38 centimeters wide and only 28 high, when I do this, you know, if it's not a square, if it's a rectangle, this still works. And you want to take whatever the smallest of the scales are to fit within that box. Okay, still fit that box. Last thing to show you real quick, just so you're aware, we talked about using attributes at the component definition level in order to select only a specific component. The way you do that typically is that when you find the view, you get its reference document, and you have to make sure you get it as an assembly document. You look at its component, and you look at the component definition, because usually edges are only going to come from parts. So usually when you're sorting through all the leaf children in a large assembly, you only really care about the parts and looking for a specific part. So you can, as you go through each leaf, if you go through each leaf occurrence, you make sure it's a part document, and then you use Attribute Manager on that part document, and you say, hey, do you have this attribute on you at all? We don't care where it lives, we just care that it is in that document. And so as long as it returns a count greater than 0, then yes, it exists there. And then that means that's the occurrence that we actually care about. Then we can start looking at it to see if it has the geometry we care about. So again, we use this to bypass components in the occurrence tree that we don't care about at all, that aren't going to contribute to what we wanted to mention. And just to show you how this works, you notice it's only looking at the attributes of the component type cheese wedge, which only this cheese wedge has. So in this particular example, when it grabs it, I'm just going to run it. It will only highlight the edges from the cheese wedge because that's the only component I care about. The interesting thing here is that, let me undo this for a second. Find attributes, there's a lot to talk about here, but you do not have to pass the find a value. You don't even have to pass it an attribute name. You can just pass it a set name. So these both have the same attribute variables on them, but they're different values. But if I don't care about the value, then it will find both. Okay. All right. I think we are done with the demo. Like I said, this example code, we'll send you links to it. If you've seen my last AVA, I actually uploaded it to the same GitHub project. So if you already have that link, just go and download the latest version of it, and you'll have all the sample code along with all the sample files. So let's get back to if there's any last minute Q&A on any of this. Lot we covered.
Yeah, let's go through a couple of the other slides first, Matt, before we jump into Q&A. So Matt went over some drawing automation today. Like I said before, Matt is one of our solution architects here on the team, who's helped kind of develop a lot of automation projects in the past. Whether or not you want to automate 5% of your process or 99% of your process, that's what we're here to help you get through. So webinars like these, and then ultimately if there's some sort of large project that you need some assistance on, definitely let us know. These are just a couple of the examples of a few things that we've gone through in the past, whether you're a tank company, whether you're a process plant company, whether you're building consumer products, right? There's automation that can fit into a lot of those workflows, and we want to be here to assist with that. And then one more slide, I think, Matt.
Oops, sorry. There we go. There we go.
Yep, and then understandably, a lot of us are working from home. Those of us who are doing it by choice or by force.
By necessity.
We have compiled a lot of resources around that. So if you do want to get some more information about that, the link there is there at the top, ketiv.com/remote-work. And that'll get you to some of our resources for things like home use licensing, for things like accessing your data in your vault, maybe off of the network, things like that. So we had an AVA all about this last week. So if you want to see more information about that, definitely take a look at that page. But without further ado, let's go ahead and take a look at questions for you, Matt.
So I did see a couple that Will put up there that I'll answer for him. So you asked about delegates and lambdas in iLogic. I don't know. I'm not sure I've ever tried to do a delegate in iLogic, so I don't know on that one. Lambdas, I believe you can. I've actually done link queries in iLogic, and they work. Matter of fact, I've had some customers after my last AVA where I showed that say that they have started using those and actually have found that it's sped up some code by doing that, which honestly surprised me. But since you can do link queries, I believe you should be able to do lambdas. But yeah, link. But yeah, link. If you know how to do link queries, it can really be a godsend, especially if you're doing complicated stuff in iLogic or in the API. But delegates, I'm not sure about, because delegates, I believe, I believe they're using addresses in the background. And I don't believe iLogic is. It's basically a runtime compiler. It's compiling each line of code at runtime, which is why things like extension methods don't work. So I'm not sure delegates would work too.
And then in the Q&A section itself, Matt, there's a decent amount of them in there too, not just the chat.
Yeah, you got to remind me how to get to that.
Yeah, it should be. Yep.
Let me find it here. Benefits of using attributes over work points. Again, the problem with work points is someone can mess with them. They can mess with the name. They can delete them. So it depends. Anything you attribute technically could be deleted, which is going to mess with you anyway. So there's really not a good way around that outside of, if you can't find it, throwing an error message. But in general, we don't always use attributes for everything, and it depends on the customer's needs. But you want to have it in your arsenal, because you will find it tends to be a more reliable way of tagging things and keeping track of them. Can we get a copy of the sample code? Yes, if I remember right, there's going to be a follow-up email that goes out to all the attendees that should have a link in it. Am I remembering right, Nigel?
That is correct. I'll have Jessica send that out after the webinar. So probably this afternoon, everybody will go ahead and receive that.
So next question is, if you have a tool similar to Attribute Helper, we can define attributes. Can you access these attributes in iLogic in order to create drawing animations? I do not know. The Attribute Helper is the best thing that's out there, and you can use it to create attributes on something. If you want to predefine them like in a text file and then use them in Attribute Helper does not do that. You can technically use attributes in iLogic because you have access to the entire Inventor API through iLogic, but there are times, because of the way iLogic works, that there are certain things that it kind of hiccups on, or it may be easier just to do it in an actual, like say a VB.NET routine or DLL. I do have some customers, because iLogic does allow you to take a precompiled DLL and import it into the iLogic to use it. You have some customers that do that. So that might get you around some things, but I'm not, it depends on what your needs are. So one of the questions is, can multiple drawing view labels be associated with a single drawing view? Nope, sorry. Each drawing view only has one label and one label only.
Cool. I think that's it for questions, Matt. Thanks for going through all of this again. Like I said,
the link that gets sent out for this AVA, that GitHub project has all the code from this AVA and my AVA in November. It's all in a single solution. Each AVA is its own project. So you'll have all the sample code. And there is some repeat sample code in this one that I've enhanced since the last one. So.
Cool. Glad you could put that together for us, Matt. I know that is always a hot topic as to like, hey, can we access this? Just know you can't plug and play it into your own stuff like immediately. You definitely want to understand what it's doing because some of the callouts will only be relevant to the stuff that Matt built. So
that's exactly right. Some of my stuff will break if you try to reuse it. It's made only for demo purposes, but the basic logic and structure you should be able to reuse. So.
Yep, absolutely. Yeah, some people I've had it before. It's like, hey, I tried using this on my thing and it didn't work. I'm like, well, did you create the attributes? It's like, no. It's like, well, there's your problem. So definitely, again, Matt, thank you so much for joining us today. And like I said, there is a survey that's going to come out after this. Let us know what you think. Let us know what you want to see in the future, and we'll go ahead and take care of it for you. Again, thanks everybody for joining us today. We'll see you again next week for another AVA. Thanks, everybody. Talk to you later.
Bye.